All right, everybody, let's get started. Happy Monday. Welcome back to the week. Yeah, another sunny week. So nice. So this week, we really get to start on a new data structure, linked lists. I think this will be a lot of fun. I get to do some drawing. I think hopefully we're all going to get really comfortable kind of thinking about pointers and our linked lists. So yeah, I think it's going to be a lot of fun. We'll spend 2 days really like implementing a linked list and practicing working with them, so that you'll be really ready for Lab 7 and Project 3, which are both about linked lists. I will go over those at the end of class today, when we have sort of some more context for that. But the one thing that I did want to point out logistically before we get started is that there is a survey, a course survey available. And this is just a quiz on Brightspace. And this is just so that I can get feedback on the class. We just did this in 112, and it was really helpful for me. And so I really look forward to hearing like what isn't going well, what can I do to change the class, because we still have half the class left. And so hopefully if there is anything that I can change, I would like to change that. If anything's going really well, I'd also like to hear about that. But it should just be 3 questions. You know, if you really don't want to do it, you can just put like a single word answer for them. You'll still get a point. So if we scroll up to the grading for the class, somewhere, it's in here. We got 2 course surveys. Each one is worth a point. So, you know, each one of these is worth half as much of a lab. So make sure that you do it. Let me know if you can't access it on Brightspace, but it should be up, open through Friday. It's not anonymous. Really, that was like partly out of laziness, that I didn't make it anonymous. So I will have your name attached to it, but at least for 112, like I didn't look, this person said that, so it changes how I think about it. Like, no, I just look at what your answers are. I don't look like, that person said that person said that. So I will have your names attached to it, but I won't be paying attention to that. So, cool, yeah.
Kind of on that note, is there any way to like link the course calendar to like the top of the website so you don't scroll down?
Oh. Well, you know, I could just put it on the top, is one thing. I could link it too. I did figure out how to link that, but yeah, I mean, I can do that. Let's see. Let me write it down. Yeah, I only at the beginning of this semester, I figured out how, in Markdown, which is what I use to kind of generate the website, I figured out how to link to a part of the page. So, oh my gosh, my pen's already. Link to calendar at top. Yeah, can definitely do that. So. Cool. But yeah, you can also put things like that in nothing is too small to put in the survey. So, any other questions about things like that? Cool. So, let's move on to our linked lists. So, last week we talked about arrays, thinking about them as data structures. What are the good things about them? Well, they can store data in some order. It's really quick to access elements at certain areas. It's easy to put things at the end, but it's pretty slow to move everything over and put something at the beginning. And also, with arrays, we have to start with a fixed size, right? And so linked lists are another data structure that functionally, how we use them will feel similar to arrays, but they're implemented differently, and so they have different pros and cons. And by the end of our discussion of linked lists, we will be able to compare them side by side. So today, maybe next class as well, we're going to be building up a linked list, implementing a linked list with these methods. But before we get into that, you probably want to know what a linked list actually is. So let's remember our arrays. So an array, it has indices, maybe starting at 0, so maybe we have 0, 1, 2, 3. And then this last one, it's going to be whatever the size of the array is minus 1, since we started at 0, size minus 2, size minus 3, etc. And in each of our slots of our array, we're storing some data. A linked list, on the other hand, we also want to store data, but the way that we're going to do that is we're going to have what we call nodes. I guess this is just one node. Oh my god. This is just one node. And in our node, we have some data. So if we imagine maybe in our linked list, we want to store strings that represent airport codes. That's just the example we're going with today. Then my data might be something like the string BZN for the Bozeman Airport. And in addition to data, we also have a pointer to another node. And so we can call this the link. And so what this allows us to do is chain these nodes together, right? So instead of storing Bozeman in this first slot here, maybe I store Bozeman as a link, and then how do I sort of represent the thing that's to its right? Well, it's just going to be another one of these nodes. Something like SEA. And that will also have a link, a pointer going somewhere. Maybe if this is the end, it's actually going to a null value, a null node. I'll write null here, which we can represent visually just with this empty set symbol. Maybe we have another node here for some other airport. And so here we have a linked list representation of 3 elements. And in order to know what the start of our linked list is, we will have a pointer to the start. And for convenience of accessing the end, so supporting things like adding a node to the end of our linked list, we are also going to have a tail pointing to the end here. And then we're also going to maintain a size, an int size, that will keep track of how many elements are in our list. And so we are going to, first, we will define one of these nodes. Do I have a? No. We're going to just hop over to some Java and write a class for a node. And then we will implement a linked list and these methods that are on this list here. But before we go into that, any questions or thoughts seeing our first description of linked list? Yeah.
Can we go in reverse order? Can we go back to the origin through a singularly linked list?
Through a single, you mean like suppose I'm at the end and I want to get back to the front.
Yeah.
I mean, I could by just asking for the head, but there's nothing, this node here does not point to the front, but there is a circularly linked list.
Yeah.
Yeah, that does exist, and we'll talk about that on Friday probably, yeah.
Can a node point to multiple nodes?
In this case, no. But also on Friday, we will see another variation on a linked list, which is a doubly linked list, where our nodes, instead of having just one pointer, a node is going to have, it'll have data, and then it'll have a node pointing backward and pointing forward. Whereas this one only points forward. And so we have this very simple description that's going to allow us to do things like adding at the front very quickly, which, and remember, an array did not allow us to add at the front very quickly. We had to shift everybody over. Yeah.
So, kind of like you were saying, could we have like a linked fan kind of option for the linked list?
Yeah, I mean, like a tree, kind of, a tree or a graph data structure. Yes, and you will learn about that in 232, I assume. We do not cover trees or graphs in this class, but very cool thing to learn about. Okay, so let's write some code for this node so that we're ready for our whole linked list. We got some Eclipse action here, day 19. So I'm just going to make a new class for my singly linked list, and I've got to make this a lot bigger. So the first thing that we're going to do is take advantage of the fact that we can nest classes in Java. And so instead of having to write my node outside of my singly linked list in another file or even in this same file, I can just have it inside of my singly linked list. So I'm going to say private class node, and inside my node, as always, I'm going to have fields, constructor. I'll just have one constructor in this case, and methods. And so this is just not quite big enough for me. All right, so if we look back at our diagram here, we can see that the node, it has some data. Today and on Wednesday, we're going to implement this just for strings. But the book actually will show you how to make a generic singly linked list, so you can take a look at that. And in the lab, you have to do this for integers, so you'll do that as well. But we can see that we have some data, and we also, like, what is a node? It's some piece of data, a string in this case, and then it's also this link. And what is this link? Well, so first we got our data. We're going to call it element, just so that it's easy for us to change this into a generic class. But this element is just that string. And then, okay, so what is that link? Well, it's just another node, right? Link to next node, right? And I think sometimes this can be a little hard to wrap your head around. Feels a little circular. I'm defining a node, but it has a node, but that's fine. My node can contain another node. So how do we want to make one of these? Let's pass in both a string, like maybe bzn, and then let's also pass in what should I assign the next node to be. So that is type node, and I'll call it n, and I need to set element to e and next to n. So now I have a way to make one of these nodes, and I need some methods. Let me just make sure that I match the methods in the book, just so that we can keep things clean. Oh, maybe I don't even have. Oh yeah, we do. Okay. So I want to be able to get back what is this string that I've stored in my node. So I got to return a string, call this get element. Doesn't need to take in anything, right? And I'm just going to return whatever my element is. And let me put these actually all on one line so that they don't take up as much space. Scoot this over. And stop me if you have questions. We've made these simple classes a lot of times, so don't want to slow us down too much on that. Let's say we want to get the next. If I want to get the next value that's stored in here, I need to return a node, because that's what next is. And I forgot that I wanted this on one line. Just going to return next. I think I also want to be able to set the next. Yes. And in that case, I'm not going to return anything. I'm just setting next. And so I'm going to set, I got to pass in a node. I'll call it n again. And I'm going to set next to n. Okay, so Java's telling me, you're not using any of these methods yet, which is true. But otherwise, I have a node class written up here that is going to be able to do everything that I need it to do in my linked list. It stores my data. It stores a next pointer to another node. And I've got the methods that I need to work with it. So now that we have that, let's think about, with our linked list, how are we going to add, say we have a linked list, how are we going to add a new element to this list? So let's say I come in here, I've got some lists already of size 3. It goes BZN, MSP, SEA. That's the order of the elements in my list. And I want to add another string in here. I want to add SLC. So what's one thing I'm going to have to do in order to add this into my list? Yeah. Yeah, what do you mean? You want to say more?
So you don't lose the sequence of what you're doing. You need to make sure that they are still following each other when you connect in the next.
Yeah. So my overall goal is to connect this in somehow, but I only have this very this kind of tenuous connection to my list, right? Which is that I need head. Like if I delete this edge right here, like if I delete this pointer and point it somewhere else, then I've actually lost all this data because I don't have any way to get to it anymore. So I definitely need to be thinking about that. And so my order of operations is going to be really important so that I don't lose that. But as a first step, or kind of something we're definitely going to need to do, is put this into a node, right? Like, whatever happens, I'm going to end up with a node, and I don't know where it's going to point yet, but I'm going to need to store this string in a node, right? So, okay, so that's going to have to happen. Maybe let's just see the whole process here. So, and this is where the kind of glory of the linked list comes in. So basically, all I'm going to need to do is kind of slot this in at the front, and I'm going to need to change my head to point to this node, and I need to change this node to point to whatever my head was pointing to, right? And so, unlike with arrays, where in order to insert at the front, I had to move everything in my array over. Here, all I have to do is just change 2 pointers. So how do you do this in practice? Well, let's jump back over to our code. So what do we want to do right now? We want to write the public void add first method. So what is this going to take in? So yes, a node makes sense, but I actually want this to live kind of at a more abstract level, right? Remember, what did I write down first? I just wrote down that we're taking in the string SLC. So we can just add in, even though we know that we're storing these in as nodes, the user of our singly linked list doesn't have to know anything about nodes. That can all be hidden away from the user. All they know is they can pass in a string. I guess I'll call it element. They can pass in any string, and it's going to be added. When I call add first, it's going to be added to the front of the list. So add a string to the front of the list. So what did I say that we needed to do here? We needed to make a node with the element data, right? So what would my syntax be for that? Well, I've got the type is node. I'll call it n, and remember, I might be tempted to call it new, but new is a reserved keyword in Java, and we would remember that because we type it here again, right? So I'll call it n. And then what is this node? It's got element as its data, and what is its next? Well, let's not worry about that for now. So let's come back. Let's look at our picture again. So if I want to know, like, what should I put as these question marks? Any ideas about, if we go back to, so this is what we want it to be. What we had before was that head was pointing right here. So, oops, well, we can just have a little double arrow there. So, can anybody tell me, looking at this picture, where should my new node point? Yeah, so we wanted to point to Bozeman, but how can I use my variables that I have? Yeah, because what is head? Head is just that first node. Exactly. So, okay. So let's go back to our picture and see what we've done. Oh, did we put any fields? Oh, I definitely did this out of order. So jumped right into our methods, forgot about our fields and our constructor. So, okay, we got some fields on this in our singly linked list. So remember, this was our this is our node, and now we're talking about our singly linked list. So we definitely have a how about an easy one, an int size, and that'll always start at 0. So I can actually just do that in the fields. We also have this node head, and we want this to start out, I guess I should make these private. We want this to start out as null. So I'm just going to say will be initialized to null. We don't have to type anything to make that happen. And I also have tail, which the same thing will be true. So forgot about those, but this is all we have. These are all the fields that we need to maintain our linked list. So yes, we've got our head. Jumping back into adding. So what we just said was that we want our new node, we're calling it n right now. N is pointing to whatever head points to, so that's what happens there. And then what's the next thing that I should write to finish this off? Anyone else? Yeah.
Head should equal the node we just made.
Yeah, so the node we just made, that's where I want head to point to, because that's my new front of the list. And so in 2 lines, head equals n, right? That's what we just said. In 2 lines, we just did all that work that was kind of hard to write down for arrays. And in fact, we can do this in one line, right? I can just say head is this new node. And this single line does both of those lines. So I set head to be some node that has the data from my input. So in this case, it was SLC. And it has, as its pointer, as its link, it has whatever head was pointing to before. But we have a couple things to think about. I guess, okay, we got some more fields. What about tail? How about, okay, let's do size first. What about size? Well, that's a pretty easy one, right? I need to increment size. Great. What about tail? Let's jump back to our picture. So, do I need to do anything to the tail pointer? Yeah, so in this case, it's looking pretty good. But there is one special case. So can anybody think of a special case for this method? Yeah. What was that? Yeah, like if head and tail are pointing to the same thing. Yeah, okay, that's interesting. So, okay, let's say they're both, let's say we have, so when would they both be, that's good because I didn't show you so when would they both be pointing to the same thing? Like, yeah, so let's say I just had BZN in here. And I guess it's the end, so it's pointing to null. We've got head and tail are both pointing to that same one. So, okay, let's see what happens when we add another one. I'll just make it small. Head points here. And it looks to me like tail is actually okay in this situation, but that was a good thought. But I can think of one other one. Yeah.
Size 0.
Yeah, what happens if size is 0? So in that case, head and tail are both pointing to null. And if we think about, well, let's think about our example. We brought in SLC. And what does our current process tell us to do? Well, it tells us to point. It doesn't tell us what to do with head, right? So it points head here, and head was pointing to null, so this ends up pointing to null, but tail's sad. So what do I need to do in this case? I just need to deal with that. So if size is 0, I need to make sure that tail points to the new node, right? So if we go back to our picture, then if instead I point tail to the front of this, or point tail to this, then we're no longer sad, we're happy. So, and I suppose we would also increment this. Great. Okay, so we've got one method down. Let me double check that I didn't miss anything. Okay. Oh yeah. Yes, because we don't, yeah, you're right. So, in fact, Java's telling me, hey, you don't have n anymore. You're right, tail is head because I changed this to only use one line and be very nice. Yeah. Yes, thank you. Yeah, the book has this in a different place, you know, if I had it above, so. But thank you for catching that, because that was an error, and we would have had a wrong implementation. Cool. Any other questions on this one? Awesome. So now let's think about, what about adding at the end? So again, let's say I came in with my SLC, and this time I don't want to add it at the front, I want to add it at the back. So let's start this off again in Java. Public void add last. Again, we're taking in a string. So, okay, again, I'm going to need to put this into a node. Let's see. I'll move it over here. So, here, what do I need to do? Well, again, it's these same thing. I just need to point my whatever's at the end here. So whatever tail's pointing to, I gotta point it to my new node, and I gotta point my new node to, I guess, really, okay, not whatever tail's pointing to, whatever tail's pointing to, like whatever tail's next is, right? So remember, if you remember our node class, it has this next field, right? And so if I want to set my SEA node to point to this, I need to change it. I need to change its next to be this node, right? So maybe not. So I think I'm going to need to call set next. And then I also want to make sure that SLC points to null, which was what tail had been pointing to, what tail's get next had been pointing to. Okay, let's go see how we can try to do this in Java. Okay, so what did I say that we needed to do? So again, we need to make this into a node, right? Node, I think we'll call it n again, is a new node. And, okay, definitely element. But let's remember, so what do I want this new node to point to? I want it to point to null, which was what tails get next was. So, I guess, okay, we'll say that it just points to null, never mind. That's a simpler way to do it. So yes, we do want it to point to null. Perfect, thank you. So now I have this, okay, I didn't need to do get next. So I've got, at this point, I've got this part done. I've made my node. And so now how do I create this link? I said tail, so tail dot set next. Yeah, and I should put n in there. And if I go back to this picture, what else hadn't I done? Can anybody tell me something I've missed in my picture that needs to be updated? I'm hearing it. Okay, all right, heard a lot of things. Okay, we definitely got size needs to be incremented. So size is 4 in my example, and size ++. Now let's go back to this picture. There's one other thing that I can see that I've missed. Yeah, I need tail to move to point to over there. So let's do that. Tail is n, right? Our new node. All right, so now we've got, let's think about special cases again. Okay, any thoughts about what might be a special case in this for adding at the end? Yeah.
So we gotta add at the end where it's empty.
Yeah, again, adding when it's empty is our special case. And that's because it's just the sort of analog of the adding first, where we wouldn't end up, we would move our tail, right? Tail would get assigned, but head would still be pointing to null. So that's when we need to deal with our tail. And actually, this is a little bit more of a special case. So I'm just going to move this down. So let's see. We'll just write this down. So if size is 0, then I need to point my head to this node, right? As well. Of course, I'm also going to increment my size. So in that case, I need to do head equals n. That's what we just drew. And if the other thing is, if this was empty, then I wouldn't really want to do my tail.setNext of n. I only want to do that in the case that the list is not empty. Okay, so we have 2 of our methods written, and I want to take the rest of class today to take a look at the next lab, and also the program 3. So let's look at lab 7. So this is the lab for this week, and really, I think you'll be well prepared for this lab. Like you should be able to start working on it now if you want. But you can, okay, let's see. You were provided some code for singly linked lists, and also a demo of that code. And this is generic, I believe. Maybe I should look at it. Yep, so we've been writing a string-based singly linked list, but you are provided a generic singly linked list, like the book does. And so you're going to try it out with strings and with movies. There's already a demo file for you, so that's what you're going to be editing. And you are also going to add a method. So this isn't one of the methods that we're going to talk about in class. This is one for you to implement. And this method is going to get you, the method's called get, and it's going to go grab whatever is stored at a given index. So I guess if we go back to our picture, let's look at a prettier one. How about just this first one? If I call get of 1, what should I return? I should return bzn, right? Because that's what is at bzn. So we assume, even though there's no built-in index like there are for arrays, like arrays, we don't get to choose. Like Java just tells us what's at 0 is the first thing. But for our singly linked list, we'll assume that this index is also starting at 0. But as you're implementing this, you'll notice that it's not very efficient. You have to loop over the whole thing. And let's see. Yeah, so it's pretty simple. I think you won't have too much trouble with this. You can also reference our scoreboard code if you would like. Yeah.
I think the sample one, it saes we're using an airport and then 2 airports are removed. Doesn't matter too much.
Yeah, I know. Yeah. Yeah, don't worry about that. Thank you, though. Yeah. Cool. Any other questions? Yeah.
I was kind of curious, like the add last method, would a null value even have a set next?
Yeah, probably not. That's probably why we don't want to. Yeah, that's a good question. So going back to this code that we were writing, if we try to call setNext on null, we're probably going to get some sort of exception. So that's why we have this if-else to protect ourselves from that. Yeah. Good question. Cool. So that's the lab. Also, the program, Project 3, again, is about working with linked lists. And you also have a similar get method that you need to have. But the main work, really, of the project is comparing the runtimes between implementing a sort of list-like data structure as an array versus a list-like data structure as a linked list. And so in the end, you're going to have this sort of test between an array data structure and a linked list data structure. And in my version, I tested 5,000. I can't remember. Maybe I require you to test 5,000. Let's see. Yep. I require you to test 5,000 adding 5,000 ints in. But we can see that we use a built-in Java class to get how long these calls take, and then finally you should print out just a sentence explaining your results. So hopefully you're getting something similar to what I'm getting, and then you can explain why you're seeing what you're seeing. So we won't go into why in class. If you're struggling with this, definitely ask a TA, ask me after class. If it's not obvious to you, you don't have to sit there and spend hours thinking about it. You can ask, but do try to think about it a little bit. And then the one thing I'll point out, so when you're writing this, so you're going to have a array data structure file, like arrayds.java, a linked list data structure file, linked list ds.java. So the linked list is going to look like what we've been writing in class. The array data structure also is going to have methods And so you're kind of writing a wrapper around an array that kind of hides that there's an array in there, but you've got these methods. So make sure that you ask about that if that's confusing. But so both array DS and linked list DS will have the same methods. They're just implemented differently under the hood. Yeah, and I think this project should be a little shorter than the other ones. So not saying, wait till the last day to do it, but I think that if you're having fun with linked lists, you can probably start this now and you might be able to finish it off pretty quickly. Yeah, that's all I really had to say today. So if you have more questions, feel free to come up. Otherwise, I will see you on Wednesday.
It's just 1 point, so I don't really entirely worry about it. But in my generic swapper class, I thought I had it right with this trying to catch. But maybe I was incorrect.
Here, let me first stop the recording.